Done, sir.
Okay. Now see, I'm going to take an example. So basically, there is alcohol like this, and it has hydrogen, and also this is OH, which represents that this is alcohol. And if you are going to react this in the presence of protic acid, concentrated H2SO4 or H3PO4, and heat it, then what happens here? This bond will be broken, and there will be formation of double bond. In the same way, if you are going to if you are going to dehydrate ethanol, ethanol undergoes dehydration by heating it with concentrated H2SO4 at 443 Cal. At 443 Cal. So you can see C2H5OH will be here. And if you are going to heat this at 443 Kelvin in the presence of H2SO4, can you name the product? Can you name the product?
Yes, sir. Sure.
Let me know the name of the product.
So can you hear me?
Yes.
Yes, sir. I was saying that. Sir, it is ethene.
Yes, it is. So you can see first, basically this CH2, and there will be hydrogen.
Sir, I can't see the screen. So
You cannot see. Is your connection weak?
yes, sir, it's weak,
Wait a
sir.
minute. Let me share a
It is weak, sir. My connection is weak. Look, that's
Can
why I'm
you
going
see
to
the
disconnect,
screen
sir.
now?
Sir, like it is there, but it's kind of just that place. I can't see the cursor also.
Can you see the screen now?
Yes, sir, I can see the screen.
Okay. So this will be the product. Please write it and let me know.
Yes, sir.
So if your connection is weak, I'm going to turn off the video. Maybe it will be helpful.
Yes, sir. So the screen changed, sir.
Yeah, sorry. It happens whenever I. Are you done with this?
Yes, sir.
Okay. Now, see, can you tell me this ethanol primary alcohol secondary or tertiary? And it which stage?
Yes, sir.
Can you tell me which type of alcohol is this? Primary, secondary, or tertiary?
Sir, it is primary, right?
Primary. Very good. You know what dehydration mechanism of this reaction is? I'm going to write a point. Mechanism of this reaction proceeds via carbocation. Proceeds via carbocation. That's why basically, as you know that carbocation, stability of carbocation. Do you know what is the stability of carbocation? So if you are going to talk about the stability of carbocation, it will be from tertiary, secondary,
And then primary.
and then primary.
Yes, sir.
Okay. So please write this, and then I'm going to write an important reactions.
Okay, sir. Done, sir.
Done. That's why secondary and tertiary, since they are stable, we will not require that much temperature. So I'm going to write a point. Secondary and tertiary alcohols are dehydrated under milder condition because they are stable as compared to primary. For example, we can take if we have secondary alcohol like this is a secondary alcohol. So we don't need 100% concentrated. 85% H3PO4 can also be good, and 440 Kelvin. That means 3 degree less, and it will be basically CH3 CH double bond CH. Now I am going to talk about tertiary alcohol. So COH, CH3, and CH3. And tertiary is more stable, so we will need 20% H3PO4 only and 358 Kelvin temperature. And so from here, this you know what happens? OH from here and hydrogen from here, here, and here. Anywhere you can take. C double bond, and then it will be CH2, and then this is CH2, and H2O will be eliminated. In the same way, if you are going for this, OH can be OH from here, and hydrogen can be removed from here and here wherever you want. Let me know when you are done with this.
Done, sir.
Very good. So I'm going to write the reactivity order also. So write a point note basically, and the note will be the relative ease of dehydration. Can you hold on a minute?
Yes, sir.
Harsh, are you there?
Yes, sir.
Okay, so you can see the rate of dehydration of alcohols follows the following follows the following order. Basically, reactivity order you can say. So tertiary will be most, and then secondary, and then primary. Are you getting my point?
Sir, you're lagging, sir.
So please write it. Am I lagging now?
Yes, sir. I don't know, sir, if it's my internet connection, but I think you're lagging, sir.
Am I able to see it? Harsh, are you there?
Yes, sir.
Okay. So this is the reactivity order. Please write it and let me know when you are done with it.
Yes, sir. Done, sir.
Done. Very good. So we are going for mechanism. So which mechanism is involved? How many steps are there for the reaction? So basically write a topic mechanism. Then please focus here. The mechanism is very important and it
Yes.
comes under 3 marks. Okay.
Yes, sir.
So what happens in the first step? I'm going to write one by one. Step 1. Step 1 is basically formation of protonated alcohol. Formation of protonated alcohol. Do you know what is protonated alcohol? Basically, if there is an alcohol, I'm
So
going
with
to take
protons in it?
this is, yes, proton will attack basically.
Yes,
You can
sir.
see there will be H, and OH. As you know that oxygen will have 2 lone pair. Oxygen will have 2 lone pair. So
Yes,
this
sir.
H plus basically attacked by this oxygen because this is nucleophile. It has more electron, so it will attack this, and this step is fast. This step is fast. So this oxygen will donate 1 electron to this hydrogen, and it will make a bond like this. The left carbon will be same, 3 hydrogen. The right carbon will have 2 hydrogen like this, and you can see if this hydrogen was there and one lone pair is on the downward, and you can see if oxygen is donating 1 electron to hydrogen, it will have positive charge, and there will be bonding between this hydrogen and oxygen. Since oxygen is donating 1 electron to hydrogen, hydrogen will get negative charge, but this hydrogen has already positively charged. So negative positive will cancel each other. Are you getting my point?
Yes, sir.
So basically this is ethanol. and this is protonated alcohol. Protonated alcohol, also known as ethyl oxonium ion, also known as ethyl oxonium ion. So this is the first step in which formation of protonated alcohol takes place.
Yes,
So
sir.
please write the first step. There are 3 steps involved
Yes, sir.
here.
Done, sir.
Done. Very good. Now see, in the second step, formation of carbocation will take place. As you know that, can you tell me positive charge on this oxygen will be more stable or less stable?
Positive charge on that
Can
oxygen
you
will
tell
be more.
me more stable or less stable?
It will be more stable. Right?
No, I told you that oxygen is electronegative element, more electronegative element.
Yes, sir.
So on more electronegative element, positive charge are less stable. And on
Okay.
more electronegative element, negative charge are stable. Are you getting
Stable.
my point?
Yes, sir.
So if we are going for step 2, you can see there will be formation of carbocation. Formation of carbocation. And how does this takes place? I'm going to write a point about this. Formation of carbocation. Basically, this second step is lowest step, slowest step. It is the slowest. It is the slowest step, and hence rate determining step, and hence rate determining step of the reaction. Always remember that the step which is slow defines the rate of the reaction. Got it?
Yes, sir. Yes, sir.
So basically, I'm going to write the product in the second first step. This was the product. You, if you remember it, this was the product basically. C H and then H and then O H, and there is positive charge and H. Now I told you that positive charge on the oxygen is less stable. So what happens? Oxygen will take electron from carbon and it will form H2O and it will be eliminated. Now you can see on the left carbon will be like this, and the right carbon will have positive charge. That means positive carbocation. Are you getting my point? Now,
Yes,
in
sir.
the second step, formation of carbocation took place. So please write this. Are you done with this? Harsh, are you with this?
Yes, sir.
Okay. Moving to the next specific. Third state, state 3. Now there will be formation of alkene.
Sir, your voice is not audible on the. I can't see the screen, sir.
This is Harsh, can you see the screen?
No, sir.
Am I audible clearly?
Yes, sir. Now you're audible, sir. I guess it's problem on my end, sir, because my internet connection is very slow.
Yes, share the screen. You rejoin.
So now it's visible. The screen is visible.
Okay. So in state 3, you can see formation of by elimination of a proton. By elimination of a proton. I don't know what's going on. Am I audible clearly?
Yes, sir. Now you're audible, sir.
Okay. You can see the screen, right?
Yes, sir. Yes.
What happens here? There will be formation of ethene by elimination of protons. So one of the hydrogen will give electron to this carbon, and there will be formation of ethene from ethanol, and H plus will be eliminated. There is a point. The acid used in step 1 released in step 3. So please write this last point.
Sir, I can see the screen, but it's not all of them. It's not visible. Like I can only see formation of ethene or elimination of proton. That's it. So can you hear me?
Yes, yes, I can hear you.
Sir, is the problem on your end or it's my end?
Wait a minute. Wait, hold a minute, please.
Yes, sir.
Yes, are you there?
Yes, sir. I'm there, sir.
Can you see the screen now?
Yeah, now it's visible, sir.
Okay. So please do it and let me know.
Done, sir.
Very good. So I'm going to give you a question on this. Please write the name of the product.
Yes, sir.
Can you do this?
Sir, just a minute, sir. I'm trying, sir.
Okay.
So done, sir.
What is the name of the product?
Wait, just a minute.
Harsh, what is the name of the product?
Sir, can you write the answer? I think I did something wrong because I
See what
can't name
happens.
this.
OH will be removed by from here and hydrogen from here.
Yes, sir.
First possibility. So the product will
CH3,
be
CH2,
CH double bond
CH
CH.
and double bond CH.
Now OH will be removed from here. Now hydrogen will be removed from here. So the product will be CH3CH because hydrogen from here remove and OH from here. So two products are possible. Yes or no?
Yes,
This
sir.
and this both are different products. Now can
Yes,
you
sir.
tell me which one is minor and which one is major?
Sir, the second one is major?
The down one.
Yeah.
Above below. So this is major because it is symmetric.
Yes, sir, it is symmetrical.
And this
sir.
is minor. This is it. What is the name of the compound? This and this. I take name. Can you name it? Harsh, are you there?
Sir,
Yes,
sir, can you hear me?
yes, I can hear you.
Sorry, sir, I got disconnected again, sir.
Yes, can you name the product? So this will be butene,
Butene, right?
but1-ene or butene, and this is
Butene, sir.
but2-ene.
Butene. Yeah.
Yeah,
Yes, sir. Sorry, sir, I got disconnected. I was just.
no problem. Now see, we have the next topic, that is oxidation. That is oxidation. So what does this oxidation means? You know that you already know what is oxidation: addition of oxygen or removal of hydrogen.
Removal of hydrogen, yes, sir.
But here, what is oxidation? Basically, oxidation involves or oxidation of alcohol involves oxidation of alcohols involves formation of carbon oxygen double bond. Formation of carbon oxygen double bond with cleavage of, this is very important, with cleavage of an OH and CH bonds. So if I'm going to explain this with an example, there is OH, and you know that to the carbon which O is connected, if there is hydrogen connected to this carbon, this bond will be broken. This OH hydrogen will be broken, and this will be also broken, and there will be formation of carbonyl compound C double bond O. So this is basically bond cleavage. The arrow shows bond cleavage of see which bond cleavage to the oxygen which hydrogen is connected, and to the carbon, and basically to the hydrogen to which carbon is connected directly. Are you getting my point?
Yes, sir.
I thought you were not there. Only two persons were there. So this is how oxidation takes place. So please write it. This reaction is also known as dehydrogenation. See,
Yes, sir. Dehydrogen. Removal of hydrogen.
Hydrogen. This reaction is also known as dehydrogenation. That means removal of hydrogen takes place. Are you done with this?
So just a minute.
Okay.
Done, sir.
Very good. So See, I'm going to oxidize alcohols. So basically, you can see this is RCH2 OH. And if you are going to oxidize this alcohol, it will be oxidized into aldehyde. It will be oxidized into
RCH.
aldehyde. And if you are going to again oxidize this part, it will be converted into carboxylic acid. It will be converted into carboxylic acid. So first step is very easy to understand as well as the second step. You can see this is basically R, C, O, H, H and H. And according to oxidation, what happens? There will be a bond broken between OH and CH. So you can see R is here and hydrogen is here. Now oxygen is simply bonded. Now you can see carbon making only 3 bonds which are not stable, so it will make double bond. So it will be oxidized into aldehyde. And again, if you are going to add this alcohol, oxidize this, there will be addition of oxygen. In the first step, you can see there is removal of hydrogen, which means oxidation. And in the second step, if you are going to oxidize aldehyde, there will be addition of oxygen that will convert it into carboxylic acid.
Yes, sir.
Okay, please write.
Yes, sir. Yeah, I'll write this.
Okay. There are some points how they are going to oxidize. So basically, there are oxidizing agents. If you are going to use a strong oxidizing agents, such as potassium or such as acidified potassium permanganate are used for getting carboxylic acid directly, directly from alcohols. And if you are going to use mild oxidizing agent like CrO3 in anhydrous, is used as oxidizing agent for isolation of aldehydes. So if you are going to use basically in alcohol, if you are going to use CrO3, so it will directly convert it into aldehyde only. Instead, if you are going to use potassium,
Yes, sir.
acidified potassium permanganate, KMnO4, at the place of CrO3, this alcohol will be directly converted into carboxylic acid.
Yes, sir.
Okay.
So what's the full name of CrO3?
Full name like?
So the name, like.
Oh, chemical name.
Yeah, chemical name. Sorry, sir. Yes.
It's a chromium trioxide, you can say. If you have CO2, that means carbon dioxide. That means CrO3 will be called chromium trioxide.
Yes, sir.
It's
So
very
can
easy.
you just scroll up for a minute?
Yeah.
To the oxidation part. Yes, sir. That's it.
Should I slide it down?
Yes, sir. I have to write that part, sir. RCH2OH. Yeah, this reaction.
Okay.
Thanks, sir. That's it. Just you can scroll down.
Please do this.
Yes, sir. Sir, the site changed. Done, sir.
Very good. Now there are other reagents which is used to oxidize. Write the point with me. A better reagent for oxidation of primary alcohols to aldehyde is pyridinium chlorochromate, also known as PCC, pyridinium chlorochromate. So basically, this pyridinium chlorochromate is a complex of chromium trioxide, is a complex of chromium trioxide with pyridine and HCl. So what happens when we are going to use this PCC with this alcohol? So this alcohol will be, there will be no effect on alkene, but this alcohol will be converted into aldehyde. Please write this. Very good. Now see, if you are going to oxidize secondary alcohols, so this point is very important. Secondary alcohols are oxidized to ketones. Secondary alcohols are oxidized to ketones by chromic anhydride. Chromic anhydride. Its common name is chromic anhydride. That means basically we are talking about CrO3. Now also, if you have something you can see CH, R dash, and if this is OH, you know that the bond between this will be broken and as well as this. So what happens in the presence of CrO3? It will be RC double bond O R dash. So this is ketone, and this is basically secondary alcohol. So primary alcohol will be oxidized into aldehydes if you are going to use mild oxidizing agent, and secondary alcohol will be converted into ketone. But if you are going to use a strong oxidizing agent, then it will be converted into carboxylic acid. Okay, Harsh. Please write it and let me know when you are done.
Done, sir.
Very good. Now I'm going to give you some question. Please do it. And please name the compound also. So wait a minute. This is can you do this?
Sir, I'm doing it, sir.
Okay.
Sir,
Yes.
done.
So can you name the compound you can see? This will be. Oh, wait a minute. Just remove this double bond, and this will be converted into CHO. Now this will be converted into ketone. And since we are using acidified KMnO4, so this will be converted into this. Yes or no?
Sir, can you hear me?
Yes. Did you get the same answer?
Yes, sir. Yes, sir. I was actually disconnected, sir.
No problem. So we are
Like it was
moving
same
to
as
the,
last question, so I
yeah,
did it.
very good. Now we have basically this point is very important. Tertiary
Yes, sir.
alcohols. Tertiary alcohols do not undergo oxidation reaction. Do not undergo oxidation reaction. Under a strong condition, under a strong reaction condition, like if you are going to use a very strong reagent, reaction condition such as a strong oxidizing agent, such as a strong oxidizing agent like KMnO4 and elevated temperatures and elevated temperatures. Like if you are going to use a strong oxidizing agent as well as very high temperature,